Hi there, welcome to section 1.4. We're going to split this into two sections or two parts. So we're going to do 1.4a and talk about some experimental design, what a study could look like, and then we'll finish off with section 1.4b. So we've got two types of studies, observational and experimental. If you think about the name of them, they pretty much tell you what they are. An observational study, researchers observe what's happening, or perhaps what has happened, they go back and collect data. So it doesn't have to be right now. We could go back to, the Spanish flu back in 1917. And then we can draw conclusions based on the observations. You have to be careful about those drawing conclusions, though, because you have to know that you have got a good correlation. There's a lot of questions and, vague parts. So for example, we could observe and keep track of people who vape. And then we could draw a conclusion, perhaps, that vaping damages your lungs. Or puts toxins into your body. The moral of the story is don't vape. It is not good for you. You don't know what you're putting into your lungs. That's observational. We just watch. We don't ask somebody to go ahead and vape to see what happens to them. That would not be an ethical decision. But if we observe and see and then check back with people, we could find things out. Experimental studies are where we actually perform an experiment. Obviously, the researcher manipulates one of the variables. And don't think of manipulate in bad terms. There's something that you're looking at and you change the directions or you change the what's happening during that. So then the researcher tries to determine how that manipulation influences the other variables of interest. So for example, students taking the SAT, you may or may not have taken that yet, are divided into 6 classrooms. Okay, so just like we always do these testing classrooms, 3 of the classes are told to do their best. Good luck, you've got this. The other 3 are told to increase their score by 50 points. Or maybe the other 3 classrooms are given breakfast and a study course the week before. The first 3 rooms scored an average of 1052. The second 3 rooms scored an average of 1098. So a significant difference. Were the smarter kids all in those, or did something happen with that manipulation of that variable? Or, for example, in preschool, toddlers were split into 2 groups. One group was told that they could play with any toy. The other group said, well, you can play with anything except for that train that's over there. Child in the second group, if you know anything about children, was probably more likely to have a tantrum or a meltdown or want to definitely play with that train. So we give different directions. We manipulate what we're looking at. So we've got some terminology that goes along with experimental studies. It makes sense when you think about it. Just like in graphing, the dependent and the independent variable, the independent is what's being manipulated. It's the directions that we're giving. Sometimes we call it the explanatory variable. And then the dependent variable is what's being measured, or the outcome. So what we do with the independent changes the dependent. The dependent depends on the other manipulation. The treatment group is the group that received the special instruction. The control group is no special instruction. They just go about business as usual. Nothing has changed with them. So if we go back to those other 2 scenarios that I just gave you, I would like to determine in these 2, let's do the SAT example. I would like to know what is the dependent and independent variables, and then I would also like to determine what's the treatment group and the control group. So if I'm taking the SAT, I'm dividing up into classrooms. I tell these 3 classes this, those 3 classes that, and then I look at their scores. So independent. So the dependent depends on something being changed. So that's going to be the actual SAT scores, right? And then the independent is what's being manipulated. We could say maybe that's the directions that we gave at the beginning, the do your best or increase your score or giving them breakfast or giving them a study course. So the directions before the test. I have to assume that my classrooms are randomly chosen. There's nothing there. That would be something to check into. So the treatment group and the control group is given no direction. The treatment group receives special instructions. So I'm going to be thinking that this right here, whatever we did for them, would be the treatment group. And then the do your best people, that's just business as usual, that would be the control group. We could go through the second example as well. It seems to me like we're looking at behaviors, and then that would be dependent, and then the independent would be what they're told. One group was told that they could play with any toy, the other group was not allowed to play with the train. So experimental studies. So we're doing an actual experiment. Advantages is that we can randomly assign participants to treatment and control groups. We just kind of pick people or for whatever we're looking for. Again, it's a random sample is what we're looking for. And in an experimental study, the independent variable can be manipulated. Disadvantages. These often occur in laboratory settings or a lot of times, educational types of classrooms, things like that, rather than natural settings. That could affect people's behavior. So the Hawthorne effect is when behavior changes because somebody is involved in an experimental study. Oh, all of a sudden they're looking at my phone habits, my social media habits, so I'm going to do less of that. So people do have a tendency to change behavior if they know that something's being looked at. So it's not natural. If that was observational, that would be nice, right? Because then I could just say, oh, I'm watching you, let's check your time, those kinds of things. A confounding variable is an interesting thing. A confounding variable is a variable that is not being studied but may influence the outcome. So let's think about this, something that might be easier to wrap our brains around. Let's say that we're doing a weight loss study. So we want to figure out, whatever. And let's say that our independent variable, the variable that's being manipulated, is diet. How and what you eat. However, a confounding variable, that's the only thing we're looking at, we expect people to just do what they naturally do. We're going to modify that one thing. The independent variable, the only thing we're going to change is how much and what they eat. So we're going to look at their diet. A confounding variable might be somebody says, well, since they're looking at weight loss, I'm going to start to exercise too. That is definitely going to change the results of my weight loss study. So increased exercise would be a confounding variable. It's not being studied. I'm not looking at that for my independent variable, but it definitely probably will influence the outcome. So observational studies, we're just observing things. This has some advantages as well. It's natural. People don't act different because they know something's looking at you. We're just watching, we're seeing what happens, we're collecting data. And we use this when it would be unethical or dangerous to manipulate an independent variable. Think about cases like we collect data on, say, domestic abuse or airbags. We don't really want to launch airbags while people are driving cars, or drugs, or wild animal attacks, or different crimes, burglaries, things like that. We're not going to ask somebody to go out and break into somebody's home. So this is something we just go back, and that's why I said at the beginning, we can go back and collect data. It doesn't have to be a current observation. And another advantage is that variables that can't be manipulated, like the ones I was just talking about, can still be studied. Disadvantages of observational studies. We really can't jump to a conclusion about cause and effect. We don't necessarily know. They may be expensive or time consuming, going back, finding data, finding participants in our observational study, those kinds of things. And often we get inaccuracies. So it's that non-sampling errors. We've got results are subject to inaccuracies. And just a little thing, you can feel free to paraphrase this. 2 different studies could be done, the same dependent and independent variables, and we may get different or even conflicting results. Again, cause and effect, inaccuracies, samples, all those things can affect things. So, keep that in mind. And that is it, for section 1.4. I thought there was more. Wow. So 1.4a, I'll see you next time. And 1.4b, have a fabulous day, everybody.